Hi, this is Steve, V6WZ. Let's talk about making some fancy-dancy PCB boards on a program called KiCad. Some of you may know that I've uploaded recently a number of different videos for various projects like low impedance 2N5109 amplifiers, some high impedance amplifiers, some phase box and antenna switching boards, and even for my beverages, the termination and feed boxes, I've used these boards as well. What I want to do is not provide a step-by-step instruction on how the KiCad program works, but just show the flow of how the program works. Going from a project design with the schematic through the PCB design itself, and ultimately ordering the board. It's really easy to use. Look, I'm not an engineer, I'm a geologist, and one evening I downloaded this program. It's a free program. And by the end of the next day, I had my first circuit board ready to go. So it's really a simple program. Some of you might say, well, why even bother? I mean, well, the truth of it is, for me, many of the projects I'm making here, I don't even need the projects. It's kind of, for me, like guys that build furniture. I just like to make them, and it's a lot of fun. In the old days, what I used to do, and maybe like some of you guys did too, of course, you'd self-etch a board, kind of like this, where you'd have a copper-clad board and using an indelible marker, mark out the traces and etch it in ferric chloride. It's more than a little bit ugly, especially when you got a complex circuit. Whereas with KiCad, you can use a two-layer. Well, I'm using a two-layer board. I mean, heck, you can even use a four-layer board. But and it's real. You end up with a really nice professional product. Anyway, let's get started. Show you how this thing works.
Find your way and navigate to the KiCad website. Google that to find it. It's pretty easy to locate. Interesting story. These guys are, it's been a bit of a history of development of this program, but lately it's been the guys at CERN have been very involved with developing this, and it's been, a great resource, and it's free, entirely a free download. So anyway, go to your download section and download the program, and you'll notice, looks like they've got lots of different OSs that it can work with. In my case, I'm using it on Windows. So after you've done that, what you'll do then is open up the KiCad program and start a new project. You open what's called a new project. I call this blank project. And then what you'll do is open up the schematic window. It's called an schema file, and you'll double click that, and that opens up the schematic window. Now what you'll want to do, I've already done this a few of them already, but then what you want to do is place your components. So let's suppose I have the schematic in front of me here, and I figure I need about 5 or 6 resistors. You press place, and then you place a symbol, and when you press the mouse in the cursor, you get a library comes up, and you can select a whole bunch of symbols. In this case, I typed in transistor and found a transistor, so I can place a transistor, and you can click it there. What else could we do? Let's say we want to place a ground port. So that would be a power port, and you can scroll. The library is quite comprehensive. There's quite a few symbols in here. Ground, okay, we'll select that, plot a ground here, and I can duplicate it and put another one here. And so what I tend to do, what I find to be handy, is I'll just populate most of the components that I need. Perhaps I need say a capacitor. So I'll click in here and find a capacitor. So I'll type in capacitor, and then I'll come up, there'll be a bunch of symbols here. The small this is an unpolarized capacitor, for example, so I can pop that in. Maybe I need a few more than that, so I'll duplicate it and put another one here. Now another thing I can do, of course, which is important, is perhaps I need to rotate this, so I can set the orientation and rotate it clockwise, so they're all in the position I want. Then ultimately, once you get your components in place, you'll do what's called place a wire. And it's really simple. Like, let's say the base here is going to go down into this capacitor, and then from it doesn't make any sense the way I have this laid out. Perhaps I need to put this ground over here, and then I can move it around, and this wire goes from here to ground, for example. And the program's very good, and it'll snap the wires to where they need to go. So I could go into this and say it goes into this capacitor, and I can add all the other types of components, including transformers and whatnot. So let me just, rather than use this, let's jump to a circuit that's mostly finished. Okay, so what I've done now is brought up the schematic, which I've actually completed for this particular project. It's a 2N 5109 push-pull amplifier where I've modified the outputs to match 75 ohms. But I did just as I was showing, and that is populated the schematic part of this program with the various components I needed, the two transistors, the resistors, the capacitors, and as I said, you can even find transformer symbols, the ground ports where they need, and the library is remarkably comprehensive. Even the relays, which I use a lot, the Omron G5V-2s, it's in the library, and the pinouts are all accurately annotated, and even the footprints are available for these particular relays. And also, and I'll talk about this in a moment, that even with respect to footprints, there are quite a number of available footprint files on the web, which are very helpful to getting the ultimate PCB layout done. So once the schematic is finished, then what you need to do is what's called annotate the schematic. And basically, when you annotate the schematic, it's basically giving a name to each of the components, like the resistors, R1 through R5 or R10 or however many resistors, transistors Q1, Q2. It's giving them a name, and it needs to do that because then the next step is to assign footprints. And what happens then when you open up the footprint assignment window, which is just coming up right now, it needs to have the assignment made for each component in order to properly allocate what's what. This is opened up on the other window. So this is the footprint, the place where you will assign footprints. So in this case, here you can see all the capacitors C1 through C10, and there's a diode and the jacks. These are my F connectors and so on and so forth. So what you'll do in here is basically assign to each of these components a footprint. All right, and you'll see here you have the footprint libraries on the left, and this can be a little bit tricky, but what you'll find is there's ways to suss out and find most of the footprints for all of these components. What sometimes you may need to do is build a footprint. I won't go into that, but it is possible, and it's fairly easy in what's called the footprint editor to build your own footprint. For example, I built my own footprint for the F connectors, and in fact, you can see this is the F connector, and I could view the footprint so you can see what it looks like, and I have to bring that over here. So this is what the footprint looks like, and I was able to build that for my board mount F connectors. And again, I won't go into it, but it's actually very, very simple to build if you need to make your own footprints. So you assign the footprints. And then say OK and update the schematic. And the reason for that is, we then need to make sure that when we export this into the PCB program, that the PCB layout program understands what kind of footprint. In other words, what's the layout of this transistor going to look like? And so what we do is we then do what's called, we generate a netlist file, and that's this button up here. And basically, you generate a netlist and save it as a particular file. I give it my name, and I'll save it. And the reason for that is then what you'll want to do is you're going to create your PC. So now that we've saved that netlist, as I say, we want to generate or begin building our PCB board, and that's why we made the netlist. What we'll do is there's different ways to do it, but we'll press this, which is opening up a new PCB board. It keeps opening up on the other window, and so this is your new. This will be the PCB layout window, whereas now you'll design the board. Now what we need to do is import that netlist. We load the netlist file, and you can navigate to it. You know where you saved it, and you find it. And then what you do is you'll update the PCB board with the netlist file. And so what you end up with is this. And I must confess, when I first started this, I thought, what the heck, what is this? So anyway, this is the canvas upon which you're going to lay out the the various components. But the way it works is, each component you can grab. So I'm going to grab the relay. So I'm going to pull this relay over here, and maybe grab this F connector. And this is where it's a little bit of work. This is where the effort comes in terms of designing these things. But yeah, just chip away at it, and it gets fun. So basically, you'll notice what's happening here is this is one of the transformers, and this right here is a resistor. I can zoom in a bit. Okay, this maybe, for example, I want to rotate this, so I'm going to rotate it clockwise, say, so I can rotate this relay. So yeah, and then here's another transformer, and I can shoot this over here, and then I can rotate it clockwise. So essentially, the approach I take in terms of so the first thing you want to do is endeavor to position the various components the way you think you want the board laid out. And just sort of chip away at it, getting it closer and closer. For example, you may know that T2 needs to be close to this F connector, whereas this transformer, needs to be, I don't know, like maybe it has to be, yeah, it looks like it has to be over here. Anyway, it can be a little bit, I'm not going to lie, a little bit of a Rubik's Cube in terms of getting all this laid out, but you keep chipping away at it and get it set up the way you want. Now, what you'll notice, of course, is what are these lines? Well, of course, these lines are showing that there needs to be a trace installed here. And then, so what we're going to do, now this is not at all ready, and I'm going to, again, fast track and jump to where I have got this all laid out. But while we're here, there are no traces. And so I'll just show you, for example, let's say, if you'll notice up here on the upper right, I can choose either the front copper trace or a bottom copper trace. In fact, I'm going to lay things out on the bottom copper trace, and then what we'll do is called place, or rather route a single track. So I'm going to say, all right, I know from this trace over to here is I need to put a trace, and I need to put a trace from this spot to there, and it'll automatically snap to it, and then say from here to here. And then I could say take the bottom or the front copper layer and say I'm going to route another trace, say from here to here, and say from here, rather from here up to here. So anyway, you're getting the idea as to how we place traces. Let me jump now to a more completed schematic so that I can talk a little bit more about some of the subtleties of laying traces. All right, so we've really jumped forward here now. This is actually my completed board, but I can just describe what I've done. So this is exactly that very same schematic that I was playing with. In fact, you can see here's the relay and the various transformers. The two F connectors are here, and here's the two transistors. And as I said, what I did initially was mostly positioned each component comparable to my schematic in terms of what I felt was the most logical layout in terms of the relative position of the transformers, the resistors, the transformers, and the F connectors, and so on and so forth. And then what I did is endeavor to get them as close as I could to minimize the size of the board. Then what we'll do is, once I do that and get them contained, I'll then put on, you'll notice here on the right-hand side, there's a thing called edge cuts. So we have to define an edge cut, and that will basically define the size of the board, and that's the yellow line, and that'll be, and so you just draw a box. You'll select edge cut and select from the banner on the right here a polygon, and you put a box around it. By the way, there's a little ruler here. You see this measuring device here, so I can take a ruler and I can measure the exact measurements of the grid and so on and so forth. And also you can set your grid limits. But again, we're getting into subtleties here at this point. So I'll put my edge cuts on. Another thing I do is I'll add what's called a copper pour, because in this case I want a low impedance ground plane. That's shown in red. I don't know if you can see this red dashed line. That's my copper pour, and I've decided to put that on the front copper surface. So again, there's a way to select that. I think you place a zone, and so we'll place a zone, and then you'll basically place your copper zone, and then in my case that's ground, and so for example, all of the components that terminate to ground just terminate directly onto the ground. So the other thing I did do, I actually eliminated some of these traces just to show you. So so I've already placed a lot of the traces, but these aren't. So as I was showing, I would say, okay, let's route a single track. But the other thing that's shown here, you'll notice, is these track widths are different, and I've done that to try and match the characteristic impedance of the various parts of the circuit, 75 ohms and 50 ohms, for example. And you'll notice here under track widths, I can select different track widths. Well, actually, you can create them. So let's say place a 1 millimeter track, and I'm going to route a single track, and I want it on the back copper board. And so we basically will go from here, and you'll notice it sort of follows itself, and it'll purposely avoid, conflicts as best it can. Oops, yeah, lock that in there. And then this one, I say come from here, and it should find its way around, and the same. So it's very, very convenient and easy to place these traces. The other thing you can do is, for example, say, I don't know, what's an example? Yeah, well, I don't know. Just say, for example, you want to move this tray. Oops, you want to move this trace, so you could go say 45-degree drag mode, and I can just move it around wherever I want to place it. You notice here's maybe a problem where I need to put a copper trace on the upper copper side, and this is a voltage line, and I can go, I can route a single track, and we can go from here. Now I can cross, of course, because it's on the upper side of the board, whereas the green is on the bottom side, and so on and so forth, until you've got everything filled out and the traces are completed. Now, one other thing you can do, which is really kind of cool with this, is you can actually do what's called a view in 3D viewer, and you actually see the board in 3 dimensions. So, and to the extent that the footprints included an actual 3-dimensional representation of the component, they will be populated, but in many cases the footprints don't include that. But this is very, very handy to be able to look at your board and and identify if there's any errors, or if it's exactly how you wanted it. You can place text. I put my call on here. You notice on the right-hand banner you can place text, but you have to make sure if you place a text that you're putting it on the front silk screen. There's the front silk screen and the back silk screen, and so on and so forth. So that's basically the process in a very, very brief nutshell. Again, not meant to be a detailed explanation on exactly how to do this, but as I said, there's a lot of tutorials online on how to on how to get through a lot of this. I did forget to say that you can also add on the front silk screen text. In this case, my component value. So this is a 120 ohm resistor. You notice I'm moving that around, and the same with I can move this print and put it wherever I want, and add labeling, and it's very, very user friendly. So now that we're done, we're ready to basically get our board made. Though one thing I would say is, by way of things to watch for, there is a thing called rules check, where to perform a design rules check, and it'll, you can run this and it'll tell you if there's errors, like if you've missed some connections or whatnot. One other thing that I kind of was a gotcha for me, and that is to say, if you've designed this, and then let's say, for example, you've got it all laid out, and then I don't know, I'll pick an example. Let's take this transformer. If I move this transformer, you notice what's happened here. I basically disconnected, and I haven't quite figured this out, I'll be honest with you. There's a way to do something called, rather than move, but you can use something called drag, and it will keep the traces with you. Be very careful, because if you've moved a component subsequent to doing your trace layouts, and if you've moved it just a little bit, what can happen is you will not be connected to that PCB board. In fact, I don't know if I can show you it here. I'll show you what, maybe, I don't know if it'll show up here. Now that I've done that, I don't know if it will. It may not. Yeah, it will. Look, okay, so do you see right here with my cursor? Notice how that's not connected anymore, all right? And that's only because I moved that component just a little bit away from its connection. So, be very, very careful about doing that, and double check your work on that. So all right, so once we're finished this, one other thing you could do, sorry guys, but look, you can also print this, okay? If you just press print, okay, the dialog button at the top, and what happens is this will print, it just prints to my laser printer, but what's really, really cool, I find, this prints at exactly to scale. So you can actually hold the board in your hand. What I mean is its exact size. So you can check your holes actually. If you're unsure of your footprints, you can actually put your transistor right on there, make sure the holes line up and the F connectors and whatever box you have planned. So I found that really handy, being able to print it and do that. Anyway, so once you're done, of course, you'll press save. And what you do then, this will now be saved in your project in what's called a .pcb file. And it's that very file that you'll use to then upload to your preferred manufacturing company to get your board made. I'm going to just show you very quickly on how I do that and the company I use. All right, so in your browser, navigate to these guys called OSH Park or OSH Park. These are the guys I use, and as soon as you get there, you'll notice right on their splash page they have a thing called Browse for Files, and you literally just go there and browse to navigate to wherever you have saved that key.pcb file. And upload it, and it just automatically proceeds to upload it to these to their server. Look, of course, these are the guys I use, and I know there's others out there. In fact, I know for sure there's manufacturers in China that will make these boards a lot cheaper, like quite a bit cheaper. I personally just try and avoid buying things in China if I can shop quasi-locally in North America. These guys are out of Oregon, I believe. But they make a really good product, and also they take a KiCad file directly. You don't have to worry about zipped Gerber files and things like that. Once your board is uploaded, you'll get a page like this that shows you basically, okay, a 2-layer board. This is the size, and 3 boards will cost $37, and that's what they cost. And that's the thing here. You have to order a minimum of 3 boards. You can't order just 1 board. So that's the reality of these guys. They're meant to be prototype boards, but I really like their product. And anyway, and you just continue along, and the shipping can be free if you choose to have them mailed to you, or you can pay a premium to have them FedExed to you. So anyway, and you can continue, and it basically shows you the top of the board and the drills and so on and so forth. I have quite a few other projects in here. These are the once you've logged on and made a file. This in fact is the same push-pull board, and I can click it and look at it in detail. Before you order it, you can see exactly, yeah, that's what I want. Anyway, there you go. That's how I proceed along and make PCB boards. It can be a lot of fun. As I said at the outset, this is a real quick, well, not quick enough video, but I just thought I'd put this together this afternoon very quickly, and maybe just to give you enough confidence to give it a try if you've never made PCB boards. It's a lot of fun, and it can be just a great project, to kill a few days. 73. This is Steve, V6WZ.